Hello friends, welcome to the session Electrical and Electronic Measurements Chapter 1 continuation, that is measurement system continuation. Okay, in the last session I started the types of instruments. The topic is types of instrument that I started. This is types of instruments. In the types of instruments, I discussed about three classifications: first classification, second classification, and third classification. In the first classification of instrument that I given, absolute instruments are primary instrument, another one is secondary instrument. In the second classification of instrument, the secondary instruments are again classified into indicating type instrument, recording type instrument, integrating type instrument. Yes. The third classification of instruments I given analog instruments and digital instrument. Then we will see the fourth classification of instrument. The fourth classification of instruments is, the instruments are broadly classified into, one is mechanical instruments. Yes, mechanical instruments. Another one is electrical instruments. Electrical instruments. Third one is electronic instruments. This is the fourth classification of instruments we are using. Okay. This is the fourth classification of instrument. Yes, mechanical instruments, electrical instruments, and electronic instrument. Tell me. But point to remember, these mechanical instruments are more preferable under static conditions and dynamic conditions. Under static condition and stable conditions only. That is, these are mainly used. These are used only under static and stable conditions. Static and stable conditions. Okay, parallelly note down, don't wait, stable conditions. Yes. One more point to remember, in mechanical instrument having large mass, because of large mass present in the mechanical instruments, it offers large inertia, and because of large inertia, these instruments are not preferable under transient and dynamic conditions, and due to this large inertia, these instruments are having less frequency response or poor frequency response. That means, due to large inertia of the instruments, these are not preferable. These are not preferable under dynamic and transient conditions. Yes, under dynamic and transient conditions. For dynamic and transient conditions, mechanical instruments are not preferable. And these instruments are having poor frequency response. That is, it cannot suddenly respond. Poor frequency response. One more point to remember, these mechanical instruments required large force large torques must be produced. Large force is required to overcome the friction. A large force is required. A large force is required to overcome the friction. Yes, to overcome the friction. One more point to remember, this instrument causes noise pollution. This causes noise pollution. Okay, all these are the drawbacks with respect to mechanical instrument. But there is some advantage also there with respect to mechanical instruments. The point to remember, because of rugged construction, these are more durable instruments. More durable because of rugged construction. Because of rugged construction. This is one of the advantage of mechanical instrument. Easy to design and easy to operate. Yes, these instruments are easy to design and easy to operate. Easy to operate. And these are less cost. These instruments are less cost. Okay, these instruments are less cost. Okay, this is about what exactly some of the features of mechanical instruments. Understood. Now see, what about electrical instruments? What are electrical instruments? Due to some electrical phenomena, the pointer is deflected and meter shows the required reading in the case of electrical instruments. Due to some electrical phenomena, pointer is deflected and meter shows the required reading. And meter shows the required reading. Yes, before this, one more point also you remember in mechanical instrument, no need of external supply or no need of power supply. In the case of mechanical instruments, no need of power supply. Okay. And due to some electrical phenomena, pointer is deflected and meter shows the required reading. One of the example is in PMMC. Due to permanent magnetic effect, a torque is produced. Because of the torque, pointer is moving. Okay, that is one of the electrical instrument. Understood. In detail about that PMMC later on we will see. Then due to some electrical phenomena, that is physical phenomena, pointer is deflected and meter shows the required reading. But point to remember here, even in electrical instruments also, whatever the moving part is there, whatever the pointer is there, that pointer is also one mechanical element. Because of that mechanical element, it is having some inertia. Hence, even electrical instruments also having inertia. Due to that, it offers less frequency response. But as compared to mechanical instrument, it is better frequency response, no doubt at all. As compared to mechanical instrument, it is a better frequency response. But due to movement of mechanical part, due to movement of mechanical element, it offers less frequency response. But point to remember, as compared to mechanical instrument, this electrical instrument will respond quickly as compared to mechanical instruments. As compared to mechanical instruments, yes, electrical instrument will respond quickly, Okay, these are some of the features of electrical instrument. Then what about the electronic instruments? Tell me. What are the electronic instruments? These instruments are implemented with semiconductor devices. That means these instruments are having semiconductor devices. This is one of the features. One more point to remember. In electronic instrument, in some applications, mainly in some scientific applications and in industrial instrumentation, quick response is required. In that applications, we can use electronic instruments. That is, in some scientific and industrial instrumentation, quick responses, fast response is required. In that instrumentation, electronic instruments are used. One more point to remember. Even small signal is also detected by using electronic instrument, because internally it consists of amplifiers and preamplifiers. Even small signal is also detected. Because of amplifiers and preamplifiers. And these instruments are having good frequency response. The point to remember, these instruments are having good frequency response. Non-contact measurement is also possible. Okay. Wherever the fast response is required, in that applications we are using the electronic instruments. Okay, these points you remember with respect to mechanical instruments, electrical instruments and electronic instruments. If you compare mechanical, electrical and electronic instruments, which is more preferable under transient and dynamic conditions? Under transient and dynamic condition, electronic instruments are more preferable, because these instruments are having good frequency response. Then if electronic instruments are not there, then only you can select mechanical instruments. But under transient and dynamic condition, we never preferable mechanical instruments. Clear? Concentrate. Quick. Note down. Okay, this is about the fourth classification of instruments. Mechanical instruments, electrical instruments, electronic instruments. Here one more point to remember. These electronic instruments are compact in size, small size, compact in size. And these instruments are having greater flexibility. That is, these instruments are user friendly. that is greater flexibility, and these instruments are have less power consumption. Less power consumption. These instruments are less power consumption. But mechanical instruments are high power consumption, but these instruments are accurate only under static condition or time invariant condition. Point to remember, mechanical instruments are accurate only under static and time invariant conditions. Static and time invariant conditions. Invariant conditions. Okay, this about fourth classification. Over. Then you go for what the fifth classification of instruments. Yes. See the fifth classification of instruments. PMMC, MI and EDM instruments are example of electrical instruments. The electronic instruments example is amplifier type instruments and rectifier type instruments are example of electronic instruments. Amplifier type instruments, rectifier type instrument is one of the example of electronic instruments. That point to remember. Yes. The fifth classification of instruments is yes, manual instruments and automatic instruments. Manual instruments, yes. One is manual instruments and another one is automatic instruments. Automatic instruments. This is the fifth classification. What do you mean by manual instruments means? For the operation of this instrument, if you want to measure the unknown quantity, it must require one operator. That means to measure the unknown quantity, operator is required. That is, to measure unknown quantity, by using manual instruments, unknown quantity, an operator is required. An operator. That operator only will measure unknown value. Then that operator can measure the unknown value. Then he justifies the what is the unknown value measured. That's why to measure unknown quantity, an operator is required. The example is measurement of temperature by using the thermistor, or measurement of temperature by using the thermometer. Understood? Then by seeing the thermometer, then you identify directly, it cannot indicate what is the temperature. You want to measure that value. Okay. Measurement of temperature by using thermistor or thermometer, that comes under manual instrument. Compulsory you want to detect. Directly it cannot give the value. But automatic instrument means to measure unknown quantity, it indicates directly, no need of any operator. This automatic instruments, no need of any operator. No need of any operator, and it directly indicates the unknown value. It directly gives unknown value. That is nothing but automatic instrument. The example is measurement of temperature by using mercury glass thermometer. By using mercury glass thermometer, whatever the temperature we are measured, that no need of operator, directly it gives the temperature value. Understood? Okay, that is the difference between manual instruments and automatic instrument. Here operator is required. Here no need of any operator. Okay, that is the fifth classification. Yes. The sixth classification of instrument is self-operated instrument and power-operated instruments. Yes, self-operated instruments. Self-operated instrument. One is self-operated instrument. Another one is power-operated instruments. Power-operated instruments. Yes. What do you mean by self-operated instrument? For this instrument, no need of any external supply. No need of external power supply. No need of any external power supply. That is nothing but a self-operated instrument. Whatever the voltmeters, ammeters we are used in the laboratory, PMMC voltmeter, PMMC ammeter, MI voltmeter, MI ammeter, all these instruments are self-operated instrument. Just we are giving the input only, but external we are not giving any supply. Na? That input itself enough for operation of the instrument. For example, there is one circuit is there. We want to measure the voltage across this resistor. We are connected one voltmeter. Are you giving any supply to this voltmeter? No, just we are giving the input value only. For operation of this instrument, this input is enough. No need of any external supply. Those instruments are nothing but a self-operated instrument. Then what is the power-operated instrument, which requires external supply for its operation? Yes, it requires external supply for its operation. External supply for its operation. Then those instruments are nothing but a power operated instrument. One of the example of power operated instrument is amplifier type instrument. Once amplifier type instrument means internally consists of its amplifiers. Once it consists of amplifiers means not only whatever the input we are giving, for operation of amplifier we can give the biasing voltage plus VCC. Yes sir, that biasing voltage is externally supplied. In detail about that you will see in amplifier type instrument. Okay, the instrument which requires not only input, some external supply is also required, then it is nothing but a power operated instrument. Okay, this about the sixth classification. One more classification is there. The seventh classification of instrument is, this is very important for competitive. The seventh classification of instrument is, one is deflecting type instruments. Yes, deflecting type instrument. Another one is null type instruments. Null type instruments. Deflecting type instruments and null type instruments. Tell me, what do you mean by deflecting type instrument? This is classified based on end of measurement. Finally, how the instrument showing the reading, based on that this classification is given. In any deflecting type instrument, there is a scale and pointer movement. In any deflecting type instrument, there is a scale and pointer movement. Yes. Then how this instrument shows the unknown reading? How this instrument measures unknown value? To measure the unknown value by using deflecting type instrument, there must be a deflection of a pointer away from 0. That means it measures unknown value by deflection of a pointer away from 0. Yes sir. Now if you want to indicate if that meter is indicating the unknown value means there must be a deflection, otherwise this instrument cannot indicate unknown value. That means in deflecting type instrument there is a pointer is moving. Pointer is nothing but a mechanical element. Every mechanical element is having some inertia. For movement of that mechanical element, we must apply the force greater than the inertia force, then only it is moving. Understood? That's why it consumes some power. That's the reason why these instruments are less accurate. But because of inertia of the pointer, these instruments are less sensitivity. Even though these are less accurate and less sensitivity, but these instruments are more preferable. Why these instruments are more preferable practically means deflection of a pointer directly shows the reading. Because of direct reading, whenever you can switch on the supply, pointer will deflect it, directly you can get the reading whatever you are measuring. That's the reason why this is less time consuming. These instruments are more preferable. That means how deflecting type instrument measures, which measures unknown quantity, yes, which measures unknown quantity, note down this, unknown quantity by deflection of a pointer away from zero. By deflection of a pointer away from zero. Next. For pointer deflection, it consumes the power. For pointer deflection, it consumes the power. It consumes the power. Hence, these are less accurate instruments. These are less accurate instruments. Less accurate. One more point. These are less sensitivity. Why these are less sensitivity instruments? Because of inertia of the pointer. Less accurate and less sensitivity instrument, but more preferable practically. These instruments are more preferable because of direct reading. Deflection of a pointer directly gives the reading. More preferable practically. Then what are the examples of deflecting type instruments? The example of deflecting type instrument is voltmeter, ammeter, wattmeter, etc. Whatever the instruments we are using in the laboratory, all these instruments are deflecting type instrument. In this, null type instrument or zero deflection type instruments. Null type instruments, or these are also called zero deflection type instrument. How this instrument measures the unknown value, which measures the unknown reading based on null deflection or zero deflection principle. SR. That means if you want to measure the unknown quantity by using this instrument, the pointer must show the zero deflection. At that condition only we are measuring the unknown value. If that pointer is not showing the zero reading, we cannot measure unknown value. Understood? That's why which measures unknown value based on null deflection or zero deflection. It measures unknown value yes, based on null deflection or zero deflection. Null deflection or zero deflection. Next. That means if the pointer shows the null deflection or zero deflection, at that condition we can measure the unknown reading. But here pointer will not measure unknown reading. But if you want to measure unknown reading means pointer must show the zero reading. At that condition only we can measure. That is the mean. One of the example is AC and DC bridges works on the principle of null deflection. Yes or no? Take the example of Wheatstone bridge. We are familiar with Wheatstone bridge, that minimum knowledge you know. When we can measure the unknown resistance by using Wheatstone bridge? Yes. Whenever galvanometer shows the zero deflection, at that condition only bridge is balanced, then apply the balance condition, we are measuring the unknown resistance. Okay, that is the meaning. But that is not the case in deflecting type instrument. If you want to measure the unknown value means there must be movement of the pointer. If you want to measure the unknown value means pointer must show the zero deflection. At that condition only we can measure. Another example is potentiometer, is also null type instrument. Understood? That means, but one point to remember, here pointer is not continuously moving, but here pointer is continuously moving. But here pointer is not continuously moving. Before coming to the zero position, it may oscillate. That's why in null type instrument, for null deflection, For null deflection of a pointer, power consumption is negligible. There is some power consumption, but it is a negligible power consumption. That's why these are more accurate as compared to deflecting type instrument. That is, for null deflection, power consumption is negligible. Power consumption is negligible. Hence, these are accurate instruments. These are accurate instruments. Accurate instruments. One more point to remember. As compared to deflecting type instrument, these are high sensitivity. High sensitivity. Then these instruments are less preferable practical. We can prefer practically, but less preferable. Less preferable practically. Why less preferable practically means? Because of time consuming. For example, take in the measurement of resistance using Wheatstone bridge and ohm meter. We are measuring the resistance by using ohm meter. We are measuring the resistance by using Wheatstone bridge. Ohm meter is one of the deflecting type instrument. Deflection of a pointer directly shows the reading. Wheatstone bridge is one of the null type instrument. Which is more accurate? Wheatstone bridge is more accurate as compared to ohm meter. But practically, which is more preferable practically? Yes, ohm meter is more preferable. Why? Because of less time consuming. If you want to measure the resistance, connect across two terminals of ohm meter, deflection pointer directly gives the reading. But that is not the case in the case of Wheatstone bridge. If you want to measure the resistance by using Wheatstone bridge means, we can bring that resistance, connect in one arm, then bring the bridges balance, then apply the balance condition, then we can measure the resistance. That much of time it takes. I told, in our daily life, accuracy is not the consideration. Time is the main concern. We don't wait for long time. We want sudden response. That's the reason why, even though these are more accurate and high sensitivity instruments, less preferable practically because of time consuming. Okay. This about the seventh classification of instrument. What is the deflecting type instrument and what is the null type instrument? There is simple classification is there. 7th, 8th and 9th classification. There is some simple classification that I want to give. No need of in detail discussion. The 8th classification of instruments is, this is based on application. The instruments are classified into panel mounted instruments, and portable instrument. Portable in the sense carrying instruments. Panel mounted instruments and portable instruments. Okay. Panel mounted means always these instruments are vertically mounted instrument. In most of the substation and generating station, most of the instruments are vertically mounted. That is panel. That is based on application I am giving. All these instruments are secondary, no doubt at all. But based on application we are giving. Portable instruments means carrying instrument. Okay, that is nothing but a portable. Panel mounted means vertically mounted, like in substation, generating station. Even in trains, AC coach also there is instruments are there. That instruments are also vertically mounted. Panel mounted instrument or vertically mounted instrument. The last classification, the 9th classification of instruments is based on principle of operation. Yes, based on a principle of operation. The instruments are classified into PMMC, permanent magnet moving coil instrument, MI instrument, EMMC instrument, yes, electrostatic voltmeter, thermal instrument, like this. This is given as based on principle of operation. In detail about that instrument later on we will see. Okay, these are the different types of instruments we are using. Okay, this is one concept in measurement system. In measurement system, one concept that I discussed, block diagram of measurement system. The another concept in measurement system is types of instruments. What are the different types of instruments we are using? Okay, in detail that I given. For example, based on this concept, simple question I am giving. Later on we will solve in classroom workbook. But here, just for understanding, 1 or 2 questions I am framing here. For example, if the question is asked like this, simple questions. Which of the following is more accurate instrument? If the question is asked like this, which of the following is more accurate instrument? Yes. Which of the following is more accurate instrument? More accurate instrument. If the question asked like this, then option is option A, tangent galvanometer. Tangent galvanometer. Option B, potentiometer. Option C, both A and B. Option D, pointing vector meter. Yes, pointing vector meter. If it is given like this, then what is your answer? Yes. Which of the following is more accurate instrument? It is not both A and B. Your answer is tangent galvanometer. Don't confuse. Sir, you told that even potentiometer is also accurate instrument. The examples of null type instruments is, what are the examples of null type instruments? AC and DC bridges and potentiometer. All these are the null type instruments. What are the examples of deflecting type instruments? Voltmeters, ammeters, wattmeters is the example of deflecting. The examples of null type. But I am telling that null type instruments are more accurate means potentiometer also more accurate. But even though potentiometer is accurate, but you compare this to potentiometer is which instrument? Secondary instrument. Tangent galvanometer is which instrument? Absolute instrument. Absolute instruments are more accurate as compared to second. That's the reason why tangent galvanometer is accurate instrument. If another example, if it is asked like this, yes, which of the following is absolute instrument? Which of the following is absolute instrument? Following is absolute instrument. If the question asked like this, that I am giving option A, tangent galvanometer. Tangent galvanometer, or before, because of this it is given Rayleigh's current meter. Yes, Rayleigh's current meter. Another one is Gauss meter. Gauss meter. Pointing vector meter. Pointing vector meter. Option D, all the above. Yes. Your answer is not all the above. Your answer is Rayleigh's current meter. But don't think like this. You don't know. I don't know about this instrument, Gauss meter and pointing vector. It may be absolute instrument. Like that, don't think. I told. In general, 4 only the absolute methods. One is tangent galvanometer, Rayleigh's current meter, absolute electrometer, Lagrange force method. Except that, if any another instrument is given, even though you don't know about that instrument, maximum, then you take that is the secondary instrument. Maximum these 4 only the absolute methods. Okay, that you concentrate. Like this, we may expect the question, simple questions like this. If you want to answer this type of questions, this knowledge is required. If the question asks like this, which of the following is integrating type instrument? Yes. Which of the following is integrating type instrument? Which of the following is integrating type instrument? Then option A, energy meter. Yes, energy meter. Option B, yes, watt hour meter. Watt hour meter. Option C, ampere hour meter. Ampere hour meter. Option D, all the above. But don't think like this. Only energy meter is the integrating type instrument. But I told how to identify given instruments are integrating. The instrument which gives the sum value or total value, that instruments are nothing but a integrating type instrument. That's why energy meter is integrating, watt hour meter is also integrating, ampere hour meter also integrating. Then your answer is all the above. Clear? that you concentrate. Question may be expected like this: which of the following instruments are not preferable under dynamic condition? Okay, which of the following instrument not preferable? Then your answer is mechanical instrument. Okay, which of the following instruments is more preferable under dynamic and transient conditions? Electronic instruments are more preferable under dynamic and transient conditions. Then in a measurement system, the sequence of different blocks in a measurement system, the sequence of different blocks, if it is asked like this, note, you remember, question may be expected like this: in measurement system, the sequence of different blocks, what is the sequence of different blocks? You tell me, that I already given. One is primary sensing element, transduction element, signal conditioning circuit. Then one more block is variable conversion element, variable manipulation element, then data transmission element, data presentation element. These are the sequence. By giving this also, sequence may be asked. This is first, this is second, this is third, this is fourth, this is fifth, this is sixth, this is seventh. This is the sequence in the case of measurement system. Okay, this about in detail about types of instrument. Then in measurement system, another important concept that I want to discuss: what are the characteristics of instrument? Okay, what is the need of studying the characteristics of instrument means? To select an instrument for particular application, first you know the characteristics of instrument. By knowing the characteristics of instrument only, then we can select an instrument for particular application. Yes, mainly the instrument characteristics are analyzed in two conditions. One is under static condition or slowly time varying condition. The another one is under dynamic condition. Now whatever the characteristics are analyzed under static condition, those characteristics are nothing but a static characteristics. Then whatever the characteristics are analyzed, whatever the characteristics of instrument is analyzed under dynamic condition, those characteristics are nothing but a dynamic characteristics. Now I want to explain in detail about what are the static characteristics and what are the dynamic characteristics. Okay, based on this, so many times questions are framed in GATE or engineering service exams. Even other PSUs also, based on this concept, questions are framed. Okay. In the next session, we will continue with that new concept in the chapter 1 measurement system, that is characteristics of instrument. With that, chapter 1 will be complete. Okay. Thank you.